Last lesson of the entire year, section 8.7, we're going to talk about LHopitals Rule. And LHopitals Rule is going to take us back down to deal with limits, which we haven't seen in a long time. And what it is, it's a really nice shortcut. LHopitals Rule only works under certain conditions. And what those conditions are is you have to be taking the limit as x approaches some value, whatever that value happens to be. And when you take that limit, you have to get what's called an indeterminate form, okay? And you have to get these specific indeterminate form. You've got to get those indeterminate forms. In other words, the top goes towards 0 at the same time the bottom goes towards 0. Well, which 0 wins? Is the 0 on the top going to win? Is the 0 on the bottom going to win? Or is it too close to call? We're saying it's too close to call. Or if the top heads toward positive infinity and the bottom heads towards negative infinity, whether the signs match or not doesn't matter. It's kind of like a race, and we're not sure who's going to win the race. If that's the case, if you do these limits and you end up with one of these forms, then what you're going to find out is you can instead take the limit as x approaches c of the derivative of the top over the derivative of the bottom and check to see if that limit works. So what this is a nice little shortcut to finish evaluating limits, but you have to have one of these indeterminate forms. If you don't have those, LHopitals Rule does not apply. Okay? If you don't have one of these indeterminate forms right here, 0 over 0 or a type of infinity over another type of infinity, LHopitals Rule is no good. So, all right, so let's see what we've got. So if I start with problem number 1, and I try my direct substitution, my favorite old DS, if I do that, my numerator by direct substitution would be 2 times 1 minus 2 would be a 0, and my denominator would also be 0. So if that's the case, which one's going to get to 0 first? I don't know. It's indeterminate. So we have an indeterminate form here. So what we're going to do is we're going to use LHopitals Rule. So if we go to use LHopitals Rule, that means that this original limit is the same as taking the limit as x approaches -1 of the derivative of the top, which is 4x, over the derivative of the bottom, which is 1. Will direct substitution work now? Yes, it will. And we're going to end up with a limit of -4. So what LHopitals Rule does is it gives us a way around it if we end up with one of these special forms. But remember, it's got to be one of those specific types of indeterminate forms, meaning a 0 over a 0 or an infinity over another infinity. Second one, let's try it again. So now we've got infinities going on here. So if I do direct substitution, what I've got is I've got 3 times an infinity minus 1 over 2 times an infinity plus 1. Well, which one's going to get there first? We don't know. And how's that really going to work out? So this is another indeterminate form that we like. So let's do LHopitals Rule a second time. If we do LHopitals Rule, it says the limit as x approaches infinity of 6x over 4x would be the same as trying to carry out that original limit. Now, you got a couple choices here. You could cancel some x's, clean some things up. If you went to do that, get rid of that, get rid of that, what am I really looking at? I'm really looking at a limit that turns out to be 3/2. Or if you wanted to say, hey, that's another indeterminate form, what's the derivative of 6x? What's the derivative of, I've got infinity over infinity a second time. Repeat LHopitals Rule a second time, you're going to get to 3 over 2. But I like the idea of doing what's in green there and canceling those out. All right, number 3. Let's try our direct substitution again. I can help with the bottom. The bottom's going to be 0. The top, e to the 0, is 1 minus 1. The top 0 also. Which one gets there faster? I don't know. This is another indeterminate form. Let's try our friend L'Hopital. If we go to do that, this limit should be the same as taking the limit as x approaches infinity. Oops, sorry, x approaches 0 of 2e to the 2x, the derivative of the top, over the derivative of the bottom, which is 1. And remember, do not do quotient rule. This is just the derivative of each individual numerator and denominator without really consulting the rest of the problem. You're looking at each of those as a separate function. So now if I go to do that limit, the bottom is a 1. That's a good sign that this is going to take me toward where I want to go. The top, 2e to the 0, is going to give me a limit of 2. Number 4. limit as x approaches infinity. If we try direct substitution, let's see what we get. So the top natural log of infinity is going to be infinity. It's going up slowly, but it is going to get there if we go out far enough. And on the bottom, that's going to be an infinity also. Look at that, another indeterminate form. Maybe every problem will be an indeterminate form. Let's use our LHopitals rule. If I use LHopitals rule, limit as x approaches infinity of 1 over x divided by 1. Fractions inside fractions. Let's clean it up. Limit as x approaches infinity of 1 over x. I've got a constant on the top. That's a good sign that this limit is pretty much over with. The bottom, if you plug a really large number into that thing on the bottom, 1 divided by something huge is going to end up to be 0. So LHopitals rule, kind of a nice thing so far. Let's look at these last two problems, kind of see what we have going here. So these last two, the first one, limit as x approaches negative infinity. So if we try our direct substitution and we do that, we're going to have an infinity on the top, and on the bottom we're going to have e raised to the negative, or to the opposite of negative infinity, or in other words, e to the infinity, positive infinity power, e to the positive infinity power. That function's going up and up and up and up. We got another infinity over infinity, just like that, indeterminate form. Let's do LHopitals rule. If we do LHopitals rule, what do we got going? We've got limit as x approaches negative infinity of a 2x in the numerator and a negative e to the negative x in the denominator. Oh, let's see. So if I do direct substitution again this time, two times negative infinity is negative infinity on the top. Negative e to the negative infinity is negative. So that's e to the infinity power with a negative sign on it. So now we've got negative infinity over infinity again. So we're still fitting. So I could repeat this again on my LHopitals. If I do LHopitals a second time, let's try it again. If I try LHopitals a second time, I've got the limit as x approaches negative infinity of 2, good sign, that's a constant, over positive e to the negative x. And now when I do my direct substitution, I've got a 2 on the top, and I've got, let's see, e to the infinity power, infinity on the bottom. 2 divided by a number like that is going to end up giving us a 0. So sometimes when LHopitals doesn't work the first time, you got to repeat it and try it again and see where it takes you. Now, the last one here, number 6, this time when we do our direct substitution, whoops, sorry, I've been trying to use red. When we do our direct substitution, we're going to have e to the infinity, or e to the negative infinity, which is a really small, e to the negative infinity. If e to the x looks like this, then e to the negative infinity says go that direction, and we're heading towards 0, times the square root of infinity, which is a really big number. Now this is an indeterminate form, but it's not a LHopitals indeterminate form, which means LHopitals doesn't apply in the form that it's in. So let's change this problem. How about limit as x approaches infinity of, what if we did square root of x over e to the positive x power? What if we did that? And now we tried direct substitution. Well, now I've got the square root of infinity, or infinity on the top, and e to the infinity, or infinity on the bottom. Now, that's our indeterminate form that we want. Now we can do LHopitals rule and see what happens. So if I do that, I've got limit as x approaches infinity of 1/2 x to the negative 1/2 power over e to the x. And I'm going to take a little detour right here. Instead of doing LHopitals again, let's clean up our fractions inside fractions. So this is the same thing as limit as x approaches infinity of 1 over 2 root x e to the x. And now if you do direct substitution with that, you're going to have 2 times a huge number times e to a huge number on the bottom. We're going to have 1 over something massive, which is going to give us a 0. But the moral of the story on that last one is when you first do LHopitals Rule or try direct substitution, your LHopitals Rule doesn't fit. So you got to get it in that form before you can apply LHopitals Rule. So that is our absolute last lesson. So I think it only fitting that we add something to the end of this like the end. And they lived happily ever after.